Okay. This is going to be a little documentation for myself as to the PDG automation workflow for the Alaska groom simulations. Um, the PDG itself took me a lot of trial and error to understand what the system was doing. I think there's still a lot to be optimized, and there's still a lot I need to understand, but this is a good reference for next time. I'm not gonna talk about the rest of this part, um, just this wedging. So an issue I was having originally was um, for for a certain animation we were doing, the settings just wasn't what I wanted the settings to be. After I was trying to move from the groom object context into like a fully SOP workflow, I was getting weird guide deformation, guide sim results. So one thing I wanted to try wedging was the bend stiffness and constraint, iteration constraint settings. So I first, because since I already had the base sim already done, I time shift. I guess you can't see any of that anymore because I overwrote it. Whatever. Uh, First I time shifted to a place because I don't want to start from zero. Zero is kind of boring. I first time shifted to a place, oh, to right here, yeah, where there's going to be a lot of head movement. And since it was already went through like a general Vellum sim, I then deleted all the Vellum attributes and kept all the stuff I had here. And then I did the Vellum stuff, and then the solver. So let's go into the top net and look at what I did. So first, wedge. Wedge is just a way. Let me generate all of this. Turn these off for now. This can go. Cool. So for wedge, wedge is just a way for us to specify all the values we want to test with. This can be either written down discretely like I did here, or it could be random or from like a range that you can set procedurally. And one thing to note, I wanted to test the bend stiffness constraint settings. Um, so you can see that it has this attribute right there. And then all of these attributes we are able to actually access from outside Houdini, outside the task context as well. In fact, all these values are available within our context, I guess, namespace. For example, I know my variable that will be changing is top bend stiffness. And then I think in bend, yeah, in here, we can see that top bend stiffness is the thing I want to set. And if I freeze this and go into my wedge, I can see the different values being set like that. So that's the wedge, and that's just driving the attributes this way. Next, this was one of the areas I was having issues with, was I wasn't really sure what ROP, I guess I just wasn't really sure what rendering, what a ROPnet was in Houdini. And I guess, and I still don't really, but to my understanding, ROPnets in this context is any time you want to render out or cache out information from Houdini to disk, including file caches. Because if we do a ROP fetch and we look into a file cache node, you'll see that the file cache node itself is actually like a container for a ROPnet, yeah, a ROPnet. I just said that, whatever. But anyway, so I have 8 variations of things I want to test, and I want that iteration to be run over 300 frames. So in here, we have to write out all these sims as caches into our folder. So it's going to be in our project folder under geo, wedge test, bend stiffness, and then wedge index, as we saw up here, is this attribute. So I was able to, so this is able to just kind of like procedurally name all your shit. And then I think that's fine for that. Next, we want to partition the jobs we did up here. So up here, you see that we have 2,408 work items, and each work item has like data associated with it, including the output source and some data, metadata associated with it. But we don't want to just pass 2,000 things to like another thing. We need to actually split it apart again. So based on the wedge index, we can split it up back into 8 chunks. So it's 8 things we want. We run in sim and cache out those 8 things. Those 8 things are like in a huge bucket by themselves in our folder structure. And then we take that data and we cache it back out into 8 distinct chunks. And this is one of those things too that there might have been a better way to do it. I wanted to do a wedge mosaic with all the hair sim results. And for me, for some reason, I was doing like a YouTube way I saw it, where we do like an OGL render, and I use viewport comments to encode the metadata. But I wasn't able to get this font size to get bigger. So 8 mosaics is just way too small, and I had to like zoom in and squint to see the settings. So what I wanted to do instead, and also I feel like 8 videos stacked together is just kind of too much. I wanted to split this into 4 and 4, right? So there's a split node, and we're splitting by expression, where if the wedge index is less than 4, it'll be this path. If it's greater than 4, it'll be this path. And then from there on, we are basically doing this part here. There's a YouTube series for wedges that's also very helpful, but I'm just going to describe. This part kind of confused me too when I first started doing it. So what are we doing here, right? We're saving all this out to a location on our disk. And then we are going into our ROPNet. And then in our OpenGL thingy, just a way to basically render this viewport essentially. We're gonna also, we want a JPEG of every single one of our sims also rendered onto disk. But we also want to do that sort of in an automative pipeline, workflow kind of way. So what I did was, for every one of these tasks, for one, we want to also run 300 frames, because we know for each of our wedges, we wedge 300 frames of caches each. So that means for our OpenGL thing, when we render it out, we also want the same number of caches. We want 1 image per frame in that cache. And then I save it out into another folder, but this time with the JPEG. And down here, under viewport comment, you can edit. This is a string variable thing. Oops, where did my thing go? Not compress, edit. You can just write the things you want to encode, and then you can resolve it and check it the same way as the other things. But anyway, that's that. And then what this thing does here is that we're splitting that into separate chunks, right? We're splitting this into separate chunks. We want to then, because this doesn't really, these are all being kind of guided by our wedge index count, but this doesn't really know, like, how do we tell this ROPNet that we want to load this, take a render of that, and then save it into our disk with the same wedge name, right? That was where I was a little confused by. I was also kind of confused by the order of things would be run in. But the idea was these all save things to a certain area in the disk. And from the documentation, I understand that partition by attribute and all the partition nodes kind of have the same functionality as wait for all, in that these nodes will kind of wait for the upstream work items to be finished in order to keep moving down the pipeline. because without the partition, without the wait for all, Houdini would try to just run all these tasks at once, which, I mean, if you try to take a picture of a cache that doesn't exist, it's going to be nothing, right? So this is going to partition everything out and save our associated wedge indexes with these sims. So basically what you have to do here then is I go out, I just do a file, and I read in the same exact path as I was saving to here, like literally the same thing with the wedge index, so that when we go down here and split, we are taking this ROPNet with the OGL thing that is going to render 300 frames. It's going to stay on this for 300 frames, and like, because there's 300 of this, it's going to run per frame. And as this is going, this file SOP is going to be also ticking from the start of the timeline based on our wedge index. So it's going to be like wedge, it's going to be whatever this thing is. It's going to be loading in, yeah, this that's the output. It's going to be loading in source wedge tests. Partition size 301. I don't know. It's going to be loading in some shit, right? With the right frames. Frame 1, frame 15, whatever. And this will start playing behind the scenes in Houdini from this in our viewport. And we have to have our render display flag on the thing that we actually want to capture, because went up. Because under the OGL thing, there is a setting that says we're going to take whatever SOP source is the display flag is currently on. Hope that makes sense. But then anyway, that's going to do that. So we can see that once we generated all the items. That's right. It should be, each path should add up to the original same amount of data we have up here, sim-wise. And this is saving up all our JPEGs. And then here, we want to, once again, partition all of our saved frames based on the frame number. So it will be 301, which is the total amount of frames we wanted to sim in the first place. And then we do image magic node, which basically just runs like an image magic operation on it that concatenates all the frames into one frame. So it should be the same amount of size. And for this, Houdini doesn't ship with, or maybe it does. For some reason, it was asking, I wasn't able to get this directory to work, or the path, so I had to install System Magic on my computer. And then after that, we wait for all. A funny thing I noticed about the wait for all node, is there nulls in tops? Is that I'm not really sure how to read data from here. Like you can, like the wait for all is really convenient, right? Because you can like merge a bunch of different shit. Like if you have a bunch of like VDBs or point deform animation caches, you have to like get done, and you don't really care about the order in which it happens in. You can just pipe all that shit into one wait for all, and then just have it all, and then move on to like a simulation thing. But similar to how, like unsimilar, I guess, to how you can like it knows if you go from this ROP fetch with all the with all the JPEGs to partition, it knows what you're talking about. That you're talking about this data, this chunk of data here. If you outside of a wait for all, I don't think you're able to do that. So you have to maybe do like another ROP fetch or something. But wait for all, it does what you think, what it says it does. It forces it, so all this shit has to cook before it goes down. And then anyway, and then you do an FFmpeg thing to finally like stitch it to make it a video. Cool. After all that, I have a Python node here that basically just sends you an email saying that all this shit is done. So I don't have to like come back and check every like 5 minutes and be anxious about it. But yeah, I think PDG is a cool way to kind of understand how Houdini paths work, how just how Houdini interacts with each other on a node to node and like a context to context level in general. I still, there's a lot of cool things you can do with it, but it's really annoying and feels like a lot of things break all the time. And this is what I meant by like 8 things is just way, I feel like that's just too much data to put in front of your face. Like I can't even read what that says. But yeah.